So let's begin with the one more module, that is fourth module. I think for AI and ML. And this module we will going to study Anaconda as software, and then Jupyter Notebook, and what are the use of Jupyter Notebook, and how can it help us in debugging the error, and how does it help us in going ahead with debugging and development consecutively. Right? Then we look for NumPy basics, Pandas basics, and Matplotlib basics. So all the last three of them are actually the packages which are basis for many packages which are using these packages as the base packages. All right, and these capabilities of these packages are also available in Matplotlib. Not Matplotlib, it's your MATLabs. Okay, in MATLAB, since it is a paid version that you need to purchase before you use it, these are the free versions of that MATLAB software copies. Okay, so the logic that you find in MATLAB is also being available as an open source. Okay, how many of you know ENC? ENC? No ENC? ENC? Matplotlib, you know? MATLAB? You know MATLAB? Use it MATLAB. Where, why do you use that MATLAB? You write a program and we run down that. Okay. Similarly, what we write program here, we also write some programs and we use some packages. So such packages are also available in Python as open source.
So difference between Matplotlib and MATLAB and Matplotlib.
MATLAB is a software which is being used to do scientific calculations, and here we are going to use Matplotlib to do plotting or representing the data in a visual format. Whose original capabilities are already available in Matplotlib. I'm saying that means MATLAB is software which you need to purchase from a company, then you need to use that. Here, somebody have already created free version of that thing, and people are using it. Capability is very same.
Only name is same, but they are owned by different entities.
Obviously, this free, that is free. Okay. We have Anaconda. Okay. We'll just go to Anaconda and once again let us revisit that software and we'll come back to this.
So today we are starting with module 4.
Yes. So already learned most of the parts of this one in the previous module also. So that's why most of the parts of this module is already covered. We just need to revise it. Let us visit the website also, where we see the Anaconda. Vinay, I am audible. So you can use Anaconda for multiple purposes. So if you visit Anaconda's website, you will see there's a download, and we have multiple platforms supported version of software. And if you download it, you'll have capability to have code into that, into the cloud. If you want to code it in the matplotlib, your IP format, that is a Jupyter book. So it will have the extension of Jupyter book. From Anaconda itself, you can launch that in, and Anaconda will control the Python as well as the packages that are installed in the Anaconda. Okay. So that way you can use it. Okay. Once we'll try that also.
And the Jupyter code,
From the Anaconda, yes. That also makes sense. Yes. PyScripts is implemented, share the infrastructure. Learn about what Anaconda is going to build. You have a video, you can have a look at that. So in terms of pricing, if you see, presently what we are using is a basic workspace. Okay. And they'll give a cloud space online, and thousands of curated packages will be available to you. On-demand training will be available, and you can publish single data application on this. Okay. I want all of you to use this free-tier cloud space in Anaconda. In the next class, I want all of you to have this account inside the Anaconda and start using this cloud space, which is free present. So, GB 200 MB hosted notebooks means IQIMB formatted notebooks. You can create 200 MB. Obviously, one notebook may have been maybe in terms of MB, 1 MB, 2 MB, 1.5. You can get around 200 files. And already have they have already installed a lot of packages. You don't have to install packages. You can directly work on it. On-demand training courses are also there.
So on-demand training courses. So what is the
I don't know. Need to check. On-demand training, a course side by side with the beginner-friendly courses and foundational Python data science could also be done. Yeah, I need to include all the things from here. Put it down. Get started. Server not running. So it is starting your server for your notebooks. So here we have nv.anaconda.cloud. Presently we are in the cloud of Anaconda, and it is opening the Jupyter Hub for us. Okay, it has allocated a disk space, storage space for saving files like Python scripts, images, and data. Here you have presently used with the sample data 12% of 200 MB. And you have been given a CPU. Since you are on a cloud, you will be given a specific computer capability that is minimum on that. So it is being given CPU usage 8 out of 1000. Central processing unit usage, CPU seconds used up only when your code is busy, or when you are running the code, then only this can be used. We have kernel being used. Kernels are nothing but the programs which are handling your processes that runs the code in your output. Okay. Then if you want to upgrade it from free to any of the chargeable things, then you can do that. Published apps presently, you are only allowed to publish only one application. If you are developing web application, then you can deploy one application maximum. On the left side, we have the file browser. Then we have the kernels or any terminals that are running that can be seen. And here we have the apps that are inactive and active. And here you have table of contents. Here you have add-ons or the extensions. The Jupyter Lab development team is excited to have a robust third-party extensions community. However, we do not review the third-party extensions, so be careful while you are using it. So that's what it is asking you to install. If you want any extension, you can enable them. But then we don't need that. So we're interested in the files. So we have some files here. You can see there's some files. Then so this is a root directory, and here we have Anaconda panel, Anaconda 2022, and we have consoles. We have other terminals, like all of them, and we have Anaconda exploration. That is our know-hows. And here we have the new Jupyter notebooks or terminal or console or any of the new files if you want to take it. We have the menu, same menu as we have in VS Code. And you can save and export the notebook. If you already have opened the notebook, you can export that and locally you can use that. You know, edit, usual edits will be there. So this will be the cloud environment that you are presently using. So if anybody also want to use that and want to execute a program, then they can just log in and they can see all your programs. Okay. So if you right click on this one, you will have a new notebook, new folder, a new file, and paste. All right. Okay. I just take a new notebook from here. So I am by default having IPYNB format. And is asking you to choose the kernel on which I am able to run that. So start preferred kernel is this one. So let us start the kernel, select the kernel, and I have been given a notebook ready for execution. And I have been given a notebook ready, and I want to rename this one. I have the rename option here. I'll go to rename it. This is my one.ipynb. So my one.ipynb is ready, and I'll be able to run the programs here. Okay. Understand these things. This is my save and create a checkpoints. I hope all of you have understood what is checkpoints. And this is your insert new cell. Like if I click, multiple cells can be created. And this is a cut the selected cell. And this is a copy. And this is a paste. And this is a play or run. Okay, this is a stop or interrupt the kernel. If the program is running, want to stop that, you can do that. And this thing we do whenever the program goes into an infinite loop or stops or suspends its process. This is for reload or restart the kernel, and this to go forward or run all the cells. Run all is the one. So here we have markdown and code and draw. And it's for the publish. Save and publish. Okay. And here are settings or render with panel, and that's it. This is the debugger. Enable debugger.
So you mentioned about checkpoints. What is it?
Checkpoint is the place where you are actually putting a marker, and that marker will hold the execution till that point and allow you to view the output till that. And after that, it will go further once you allow it to go. That's what we need to help you in creating the checkpoints wherever you want to put it. I mean, I want to look at the execution till that point. After that, whenever I tell go next, it has to execute further instructions. When I say next, it has to go further execution. At a time, all the things it should not do it. So I will create a checkpoints wherever now. Got it? That's their checkpoint.
The same way, we are creating breakpoints also or breakers. Both are they similar?
No, both will be different. We saw them in respect to our VS Code programs earlier. Keep it. We have some bigger programs so that we can put a checklist into that. Okay. Here I have added breakpoint. So for the same place, you can also add the breakpoints when you are running it. Let us run this. It is visible completely. We need a .py file to have them clearly visible. So I have my breakpoints being added, and whenever I want to have the save points, I'll be able to see all the execution, and I'm also taking some action on them. Okay. So here breakpoint means they'll be breaking the control of execution. That's why they have been told as breakpoints. I've added 3 of them, and I'll be given such control. This control I'll be having. Right? So this control I'll be having, and this will give me a control over continuing. This is my step over, step down, step into, step out, and this is my restart. And at last I have disconnect. Yes. So they happen during the debugging. So they are all tools, and what you can say the debug handling or debugging process tools they are actually. When you're debugging, you wanted to have more control over the lines of the code that you're written. That's why tools are available as tools. Let's check points. Yeah, you can use Python PDB, and you can use programming check breakpoints as well as the checkpoints to be placed inside the program. And you can also trace the flow between your programs and the flow that you have set in the debugging. Okay. So further, you can execute them move this cell up, move this cell down, and this is for inserting another cell that is above, adding another cell below, and this is execution. So whenever you execute it and play, it takes some time to execute it because you are on a cloud and it takes some time for execute. You are sending this request that this data on your browser you are typing something. This statement will be sent to the server. Server will execute and send back to the output to you on the browser. Okay, it is similar to your you are sending something from the form. This is a form. Okay, you can consider it as a server, but this is a form that has been opened from the server's files. Just similar to that.
So this is called as what's the cloud programming.
This is cloud hosted Jupyter notebooks. Cloud hosted Jupyter notebooks. Then
And also
hosted
called as cloud programming.
cloud programming can be programming which is affecting the cloud capabilities. But then you cannot modify the capabilities of the cloud. Programming the cloud.
We are doing the program through
Using the cloud to do the programming. Okay, let us play this. Yes. So this is very fast. So when you click on that, so it's clicked. Now my focus is on this one. This is my focus. And next the focus is controlled to this one. So that's how each of the lines that are available, wherever you have focused it, next lines will be executed continuously. Now if I'm here, continuously from here it can execute. You can look at this movement that is happening. Alright. That is what it makes Jupyter notebooks or the Python notebooks will have the edge for development of interactivity between the multiple cells. So now multiple cells here are actually interacting with each other. As I told you earlier also, that if I have this a equal to 10 here, and I can also print my a equal to 10 here. So if I ask what is a equal to 10 before executing this one, here I can see some yellow lines are there. So execute it. It says something error is there. That means a is not defined because this has not executed. Okay, so that's the demo here I am giving is here I am printing a value and I have initialized in the previous cell a equal to 10. Now it is saying a is not defined because this cell has not executed. I have not run it. I just deleted it. So once I run this place first, then I run this one. It says there's a 10 available. Alright, that means wherever you're writing the variables, that has to execute first. Then it has to execute the next one. Alright, that's how it is going to help you in creating multiple cells with the multiple variables, and you can handle the or use the previous cells variables also in the subsequent cells. That's what we mean.
So each time we do it like this.
Each time.
Each time we will run after that.
If you are running the programs which are connected to all of them, if you make any changes to the previous programs, which you want to be used in the further programs, then definitely you have to run all of them in the sequence. Okay. To run that at a time, you have this button. Rather than clicking this button, you can click on this button as well. If you click on this button, from the start, it will run it. No problem at all. Let us run this. This is my restart kernel. Yes. Yes, it's running it. So you can also restart your kernel. This is a kernel, not for all the code, not run all. Okay. From here you can run all of them. I hope all of you got the capabilities of this Jupyter notebook. All right. not running on your computer, you can just open the browser and you can log into this one and you can run from here. Your capability of RAM of the laptop is maybe less, but their capability is more. That's why they are asking you to use their CPU here. They give 1000 instance capability. You can use them. Alright? So get back. So since we are in an Anaconda Navigator, we'll have a home, we have environments. In home, we have all the applications that are installed and not installed, and the applications which are need to be updated. And we have here the base, that is root, is the one that is being selected. We already have a lot of packages are coming as a pre-built packages once you install Anaconda. So if you create another package, if you create another environment from here, you have to install packages which you need to specifically want it. Like I am going to go with an NumPy, Matplotlib, and Pandas. I need to install them from my own. Okay, if they are not available by default. So few of the by default packages will come. So other than that, so you need to install all of them. But initially, when you are present in the base, so all the packages, most of them will be available by default. Okay. So from here, we can create the packages. We can create an environment. Why do we create an environment? We create an environment because we wanted to maintain multiple versions of packages, Python packages. What do? They provide us the capabilities of using functions as well as classes to complete our task easily. Without writing our own code, we can use already written code by some other developer, and that code is available as with a name called package name, and that is already installed in your environment, and that version is the one that you have just now installed. After 1 year, you want to use the same package, but after 1 year, the package have been upgraded. Somebody might have upgraded the code also. So you don't want to use the upgraded code. You need only the old code because your project runs on the old package only. Okay? If you upgrade the new package, your project will not run. So in that case, what do? You create one more environment. You install the new package that you are looking at here. That is upgraded. You install the new environment, and you start creating new project on the new updated package. So you are now maintaining two packages because your project runs on old package, one project. Another project that you are creating from today is going to use the new package. Same name, versions are different. So now in the single computer, we are maintaining two different packages of the same name. That's why we need to have the Anaconda's environment to be created. So whenever you are executing your project, whichever project you are executing, you have to switch between environments. If you want to execute an old project, go back to the old environment, switch that, execute it. Now I decided today that I will go to my new project. I have to switch my environment. Then I will be working with that. Alright? Okay. Let us see if I can create the environment here. I think it is giving an error because of some issues. So let us have a see. So I'll create my environment 1 with the latest Python, that's 3.11. I'll try to create it. So it's giving me some problem. Give me address of any of them. Let us try. Tell me the latest number of any of them.
176.
176
666.
226 107.
Yes.
Can create from the enabler or there are commands to create the environments. Alright. Yeah, there's a problem with the command itself. Just run it. All of you open the Anaconda. Try to create the environment. One environment. Try to create.
I need a sensor disconnect.
Okay, you can use it from there only. Create from there only. I'll just see. You open the Anaconda. It is already open, right? Wait for that. It's already there. It's already there. Don't look, it's not right. Respond. Yeah, great. 3.9.
What's that location meaning, sir?
Which location?
It's giving the path of the environment.
Where it is created. If you want to look back again, where you have to look back. Yeah, use that one environment. Another environment we use 3.11. Okay, create that. Try to maintain two versions of Python. Two environments created with different versions of Python.
So while leaving the environment, we'll mention of the P11 or P9 like
Yes,
this.
yes. Valid variable names.
So that will be useful for us to understand.
Yes, what kind of
So once the environment is created, can we rename it?
yes, you can again. That is actually I thing you can't rename because it's already creating all the files internally and it is making it. Let us try. Create it. Did you create it? Any problem? Still. Create it. Yes. Good. Create. I'm creating for 3.1 months. 3.1. 11. 3.11. 3.9 also. That's mandatory versions. Should quickly fast. It's working. So, let's go. Let's go. You can also create from command line. I'll also give you the command line. You can remember that also. From command also you can do it. What is opening? It's opening base folder. So, set what's there is a command to create the new environment. Command is the conda space create space hyphen name, and then you can provide the environment name. env. If I have 3.11, I am going to give underscore 3.11 as a package. Okay. When you press enter, it will give you the environment. Sorry, the environment done. Collecting package is done. And it is showing you in this location, I want to install my package. Do you allow them to install the package? Okay, to activate this command, okay, it is executed successfully. So to activate this environment, you have to use the command called conda space activate space your environment name. Your environment name is env underscore 3.11. Yes, my environment has been activated here. That is how simply you can just run the command and you'll be able to have it. Alright, all of you. But you have to be in the administrator command prompt, then you'll be able to execute also. Try the command also. Go to the start menu, open the CMD, and once you have the CMD, right click on the CMD, and run as administrator. Once run as administrator, we'll be having the black prompt. They will write conda space. Command is conda space create. Conda space create. Conda space create space hyphen minus name Space, the environment name that you want to give. Space, right now is the main, space package name. Or environment name. What your environment name you want to give? That is an okay. Close this one. There are so many. In the take the NS here.
Is that?
That is the NS, you take it here. After that, you yes, also done.
So how to delete the AMDs?
Yeah.
Any other? Because I have created a multiple.
Okay. Second set command.
India one I want to delete.
You can also delete it from here. Remove.
From there I remove once.
Okay. Two more. Okay.
Sir, by creating the environment, will it be activated sir? After creating, we have to activate it.
Right. You have to activate first. Automatically, you ask because if there are 10 environments, if you're creating new one, which one is activated? That's activated.
So by deactivating environment, it will get into the passive side, but it will not be deleted from the.
This not focusing on that.
But it will be there.
Ah, it can activate it, yes. You can use conda env space remove. Conda space env space remove space name of the name you have to use. Right, let's do one of the command prompt. Conda space env space remove minus -t. Yes, any problem? You can also remove them. You can also remove the environments if your page already ready. You can also remove them. Okay, and there is a command you can try once. Type the command and try. All of you can see the screen. Conda space env. Conda space env space remove. Space remove. Space remove env is env. Just a second, I will increase the size. Yeah, space hyphen name. Then we need to provide the name of the environment that you have created. Which one will delete?
We delete 3.9
P version 3.9.
or EMV underscore 3.1 sir.
That we can delete.
Yeah.
env underscore 3.11.
Yes.
Okay, after the hyphen name, you can give name env. Package name you have to give it. This one. Whatever name you have given, package name, environment name that you have given, that you give it.
EMV underscore 3.11 sir.
Alright. Any package any environment that you have created, you can remove with the help of this command. Do this and check. No. This is the name that you have created. Like I have created some ENV one. Environment name. We check in environment variable, environment list. You see all this list, right? This list you have it. Okay. This list, whatever name you have seen, that name you have mentioned. Okay. Mention that name here and press enter.
So invite the CMD process.
Okay.
So that green screen and this black screen, you can see
Side by side.
Yeah, side by side you can see. Now it's creating in environments areas.
Okay. Yes.
So whenever that blue line that passes below to the white screen, either it is created or deleted.
All of you done? Understood? Understood? Okay. This all of you practice. Thus, now we try to maintain two different versions of NumPy in two different environments. Okay. I hope other than base, you have created two different environments. Is this available? Yes. Okay. Let us create that thing, and let's just check what is the present version of NumPy. Present version of NumPy is 1.2.25.0. It's a release history. Okay. In one of the environment, you can use NumPy 1.22.0. Okay. 1.22.0. And some of you, another environment, you install 1.25. Okay. Let us try first this one. So you can use the command. I will tell you how to use the command. In your VS Code, you can go to terminal, or you can open the terminal like this also. I'm using terminal in VS Code. And I'll first go and activate my environment. That's my first basic work to look at on the left side of that. And in the left side, I can see the base. If you don't look at that, here I am to activate my package environment. How to activate that? Conda space activate. Okay, then package name. The environment name. What is the environment name that we have here? We have
3.11,
3.11, 3.9. We have create environment. I'll create new environment. I say my env1 is my environment. Okay, I have created an environment. You can also use conda space list. Conda env list. When I say conda env list, I will see all my environments being listed. Conda space env space list. Try that. Conda space env space list. Env is for environment. Okay. Try that command. You see all the packages available. So this will help you in knowing the names of the environment that you have created. All right. Let's activate one of them. Activate space. Conda activate space env1.
So Conda is common across all those commands. So we can do with env list, we can do with activate env1. Why insert Conda every time?
Because Conda is going to become a handler of all the tasks, manager.
So we are including this Conda because we are doing this through command accounts. Otherwise, if we are doing in Conda environment itself, that website itself, we need not include this Conda every time.
Obviously.
Because we are in the home itself.
Again, we need to tell what we need to do from the general command. Okay, I can see on the left side in the brackets env1 activated. How you can see this? Whatever names of the environment that we have given, sir, that need to be there. Conda space activate space environment name.
So whenever we are doing this task through this CMD or VS Code terminal or the one from the invoker to desktop,
You have to use
yes, we have to use Conda.
Is it done, all of you? Are you in this? Okay, let us install a package that we are looking for. Oh, it is connected. Accept it. Okay, as I told you, we have a package called numpy, and this is the name and this is the number. Let us use that. It is numpy, numpy 1.25.2.0. Okay, pip space install space pip space install space numpy equal to. If you directly install without this anything writing after this, you will install the latest version of numpy. If we look for latest version of numpy and install it. Presently, the latest version is 1.25. Directly if you install or if you mention the version, same thing. It will install the latest one. Install the latest version in this one. No problem. Okay. Press enter. We'll mention again. And this is latest one. I'll tell you how to mention the version in the next environment. Requirements already satisfied. That means already it has installed the numpy. Pip is saying it is not installed, so we can install the pip also with the help of Python space whatever is that. That will do it later. But let us install the Python version. Different version of numpy in different environment. And now I want to switch to another environment. What do you do? How to switch to another environment? Conda activate. Yes. Conda activate. I need one more name of that. I have P version 3.11. Yes, presently I am access to the different environment now. Now I'll do the same command, but at this time my numpy is not default. It is going to have equal, and now I'll be giving 1.20.0. Any different versions that you have, you can browse it online and you can look for that version and you can look for. I mean, you can have that.
Whenever we are installing the different versions, so we need to make use of assignment section.
Yes. Equal version. I'm taking this version. Any version you can pick it from online. And pick this one. This version I am taking it. And I am in different environment. Remember this left side, you remember this? Earlier I was in ENV1, now I am in different environment. I switched it to different environment. Now I am going to have specified the version here. Now let us press enter. Now it is downloading in different environments. Earlier it has told me that I already installed in my environment, so I don't have to install. Now in this one, I am installing different version. It is installing. If any older version is there, we will uninstall it. Remember this one also.
In that environment.
Yes, in that environment, if any new version is there, and if you are trying to install the old version, new version is uninstalled, old version is installed. Remember this one. It will replace it. That is it. Alright, it will replace the versions, whatever you are using. Same thing happens for old version also. If you are having old version, if you want to upgrade it, old version will be deleted, new version will be added.
But we will write the program in the old version.
That's what your program will give you error.
But how to use it? You want to
Again, install the old version.
Old version you have to install.
again.
That's why there is a environment system. For your project, whatever supporting versions are there, you create environment. Only those versions you install in that. Don't disturb those versions. Create another environment. There you install any other new latest versions. Don't touch that existing versions that you have created separately. Alright? Yeah, it is installing. Getting wheel for NumPy did not successfully run. So it has given you some problem. It may not yet be supported by Python. So you have to install the newer version of that. So let us look for any newer version that we have. We can install 24.2, 24.3, any one of them.
23 is not there.
23 is there. 24.1 we can try. 24.1 we can try. Since that was the older version, it is not supported. Let us see in this one whether it installs or not. So you can see here it is saying successfully uninstalling the previous version. And installing this version.
So the latest version installed was 124.3.
Yes, not installed.
That's installed now and
Yes, installed. Here it gives a message successfully installed NumPy 1.241. That is how you specify the version and you install it. Now we are able to maintain two different versions of NumPy in the same computer. Okay, that's how you can run multiple projects which are supported by multiple different versions of packages in the same computer. Okay, that's what you need to take. Yes. Huh. What else? The it does not give any account. Following dependency. Conflicts. Conflicts, obviously. So you're saying you do not have the latest version installed. So other packages which are having latest version may give you conflict because some of the packages which people are developing are actually using the latest version of NumPy as a base version. Using those methods or method names, they have created the new packages. That new package actually want before installing its own package, it has to have its base package installed. Get it? If you install the NumPy older one, and if they have dependency of newer version, then your new package will give you problems. It says I want new one, where is new one? You say I have old one, no, I will not run. So that's so. At that time, when you use some packages which are not supported by old version, you have to upgrade it. Obviously. So now, if you want to upgrade, you can upgrade it. Directly use NumPy and it upgrade it. Okay? Yes.
When running different projects, how to remember this project was stored in this environment, this was the version of NumPy, this was the version of Matplotlib. How to remember all those things?
Yes, good question. So we will be creating a file called requirements.txt. Requirements.txt in all the Python projects whenever we deploy or whenever we create a complete project. What happens when we create that file? We can run that whole file to install the packages, not by one by one means. Like NumPy I'm installing for this version, another name I'm this version. I'm not using that method. I'll be just storing all the version along with the names, and I'll be running the whole file. For example, if I have 50 packages with the version, I'll run the file. So all the packages available in that requirement.txt will be run. Alright, that is how you can install all the packages supported by one project. And we definitely will not forget that because you will be stored in file. Create an environment, run that command. All the packages related to that project is installed. Run the project comfortably. No problem. Understood? That can be done. Okay. If you want to do that, we'll do that also. You have to do that. Yes, update directly without version running. Keep workspace install space the name of the package. So consider this as one other project, and there are a lot of folders available in this one. And in this project, there is a file called requirements.txt. I just look at that file. You can see there are a lot of package names that have been installed. These names are listed one by one below another. This file you have to run it. Okay. I think it will be run with the -R, that is for -R. You can use it as a command and you can install that. Let's install that also. Which thing, I mean, which one you want to install? Any package names you know? Mat.lib. Notepad, I'll open it with in this one, mat.lib. Then,
so when you open Notepad,
because I want to create a file, and I want to show some names.
or names of all those packages which you want to run later.
Yes.
So we install -R.
Yes. -R space name of file. Mat.lib. Then, any packages you know? We have tkinter, we have Flask, Pillow, MyGame, the Django, we have Swagger, TensorFlow, we have Beautiful Source Code. Okay, we have a lot of packages. I'll take few of them from here. Okay, I have stored my names here, package names, and I'm saving it. I'm going to close this, and I just check whether my file exists or not. Yes, I have my file exists here, and I'm going to install this packages in this environment.
How to check whether my file is existing or not?
dir will be the command.
So you give all the contents of the directory.
PowerShell, focus here. Pip space install you are actually doing earlier. And you're typing the package name earlier. Now, instead of writing package name, we have already stored the packages names in the file. And at a time, we want to install all of them. So let us try that. -R will be the command. and then we have to write the file name. Yes, this is my file name that I have, requirements.txt. Alright, let us install that. So let me open that file also where we already stored it. I have a F drive. F drive. This is my drive.
Yes, my system is okay.
We have started installing one of them. It says requirement already satisfied for matplotlib. Matplotlib already installed. This is installed. And installing this one now. TK latest version of this game. Pi Auto GUI. Whenever any application, any package is getting installed, we'll first install their base package. Like for example, if I'm using if I'm installing the calculator package, then it will install first addition, subtraction, multiplication packages. Then it will install its calculator package. Without their basic package, it cannot operate. That's why it install the basic package first, then it install the major package, the parent package. That's what it does. So it will install any dependencies. We call them as dependencies. So dependencies will be created, installed first, then the major package that we have. So it is installing all of them, all the packages. I hope all of you have noted down the command. I'll repeat again the command. The command is pip space install space -r space file name.txt. Any file name that I created, that file name.txt. I'll repeat again. Pip space install space -r space requirements dot txt, and that file one line one package name must be there. Requirements dot txt. Txt is the extension of the file.
Instead of Notepad, can I use a MS Word file or an Excel file or a PPT file?
That is having more data stored as configuration files. So that cannot be a simple file that we can give it as a command. That is a check. I have everything ready.
So first we have to create a PPT requirements.
Yes. Now the document. Try to install that. And you'll be able to see. It's taking more time. You try to run this thing. What is the name of the file? If the name of the file is a new document, you can save it with a different name, and you can run that. Run desktop. All of you understood? Understood the environment? Yeah. Just tell you the story. Just remember that. So what we did initially was we created an environment. So why we created? Because we wanted to mention and store different versions of packages. And the question comes is, why are we maintaining multiple versions of packages? Because I have to see which project are managing which type of packages or which type of packages my project is used earlier. I am not upgrading my program because I have already created a whole project. I am not going to change because of the new facilities that has been added in the new packages or updates. So that's why I want to maintain my older versions. Since my system is already installed with the latest version of the packages, my project is currently not working. So I want the older version of the packages. So I will create an environment. So there I will install all the requirements.txt packages. I will install once, all of them, with the command called pip space install space -r space the file name required file name.txt or the file name that you are giving me. So once you install all the packages which are supported by your project, then you run the project smoothly to run. Because your project is supporting only those versions which are there in the requirement.txt. That's why whenever you create a project, create a requirement.txt file and store the versions that your project is supporting. Presently, whatever latest versions are there, that you write. Okay. Here we have written with the help of equal operator, as you can see. Okay. With that, you can install the package versions, and you will be able to run the projects. And if I want the latest version now, I have already run my old project. Now I want to use my new packages also. I will not erase my previous packages, or I will not update my existing packages where my project is running very smooth. I will create another environment. There I will install my latest versions. Alright? The standard process that you can follow in your laptops is keep the updated versions in the base package, which is by default. Alright? The base environment that you have already existing initially when you install Anaconda. There you keep all the packages installed, updated, latest one. In any packages that you want older versions, or any package, any program, or any project that you're taking from internet, and that is not running with the new version, create an environment, install all the requirement.txt packages in that new environment that you created. In that, you install it as well as run the new project that you're taking on. Alright, that is how you can maintain multiple versions and also keep the computer safe from the project execution. I mean, you can execute the project without disturbing the existing versions of the existing work that you're doing. Alright, else you mess up with a lot of things. Only one environment is there. Once you're downloading a project and you're trying to run it, and it's asking one package is not there, and you're installing it. And it is asking one more dependency is not there, you are installing it. And after that, your normal programs which you did earlier, for a week, it is not working. This happens. This must not happen. You must know this before time, before you commit those problems. Safely, create the latest version of my one environment, separately is there. That is for my regular process. I will create one more environment. There will run my all the projects that I am downloading from internet or I am referring some any reference. And you doing this thing. That you make sure, and you are very clean. You will not be able to distract from the work. Alright, that is how you maintain the packages because of in a that is it. Okay. I understood how do you create the requirement.txt file and you can save them and you can install them. I hope you understand that. Okay. Let's go ahead.
So it's created on the source.
Which one?
MS Word file, sir.
Okay.
Nothing FTS in Word.
Okay. Yeah, you can run it later, please. I hope all of you have understood the Anaconda. You can also use home, and here we have a Jupyter notebook. From here also you can launch it. The notebook that we saw online on the cloud, same thing also you can see on here. This will launch on the browser. Or you can launch the notebook from your Anaconda.
The difference between lab and notebooks.
Lab is complete environment will be given to you with storing files, maintaining the project, uploading the files, and then it will be there. Lab where you do all the experiments, all the data. In the notebook, you only have one file.
Just for coding.
One file is notebook. The lab is complete setup is there. Yes, we can see we have opened the Jupyter lab, and here we have different files available that is of your computer presently in the room, and I want a new file. I am taking from the right side on top. We have here Python 3 IPYNB kernel. When I clicked on that, it has given me this environment. So here also I can run my Python program. Alright, I'll show you again. We are actually in the browser, and it will show me this kind of a page. Okay, you can, if you have already created some IPYNB files, like I can see here already, you can open them. Okay, like I can also go on my desktop. I can also go on my OneDrive. So download files, so all of them. So you can also go to those files and you can understand and you can open those folders or files if you already created a programs. If you want to newly create a program, you create a new program on the from this side, from here. All right, I'll open the existing file. Where can we find the existing file? Demo 100 we have it. Do we have IPYNB?
Yes. Some programs are into IPYNB format.
Yeah, we have IPYNB format files here. I'll open one of them. You can see I have opened one of the existing file available in your computer. You can open that and you will see it is available on your Jupyter lab. It's already running. So whatever we saw on Anaconda Cloud, same interface you can see, and you'll be able to execute all of them. All right, how to do it? Do it fast. Remember, backup is off. Slow. Slow. Delay. I told that. Is it done? Yeah. I have told you in Anaconda. After that, browser is opened. Just see browser is opened. In the last bar, if you see the browser is running already, in that it is not launching. It is not launched.
It's showing files.
Files showing right. Then you have this interface ready. I'll just show you. Just a second. I think it is showing like this. Right. Then you have to read those folder names. What are folder names you have? You have desktop, documents, downloads. You have them?
Yes, sir.
Okay. On desktop, do you have any files? Python programs already stored. Go to desktop. You go to desktop. On that, which folder you're having those programs? Having? Open any of the IPYNB file. Look for IPYNB file in any folder. And just open the file.
So,
Yes.
sorry, it was showing the VS
When you click on to IPYNB file, here you're clicking on IPYNB file. Like I have, for example, I have some file here. On this one, it is going to OBS code. Is it? Yes, sir.
When you click on Jupyter,
So open browser actually. It is written on that. I just see on the Jupyter lab is one description. Web-based, web-based browser. Just like that.
when you click on here, launch, you get a URL code which we need to paste to the web browser.
And no,
Then we need to go to web browser. So Jupyter Web is open here. So this Chrome.
Which has to open on that means the receiving files are actually opening in browser. Why it would have to reflect that? It has to be checked what in the this one. Is it done? Okay. So in that extension, you can install any other applications also. There's one more thing here: an extensible environment for interactive and reproducible computing.
So in the Jupyter notebook is telling 6.4.1 is that the version of the Python?
6 point. No, that is not the version.
Notebook version.
That was software. They have no. So if you click on Jupyter Lab, you will see this interface, which we saw on Anaconda Cloud browser before. We just opened it, and in Anaconda website we went and we registered there, and we went inside the Anaconda's cloud. There we saw this kind of environment. That was actually the environment called Jupyter Lab. Okay. So how about this one? This is my Jupyter Notebook. Okay. In Jupyter Notebook, you can just do some programming individually on a single file, like this. And in Jupyter Lab, you have all the file storage capabilities. You can create a project here, and you can maintain that project into this one. And you have many tools other than that also. Okay, like these tools you don't have in Jupyter Notebook. This is my Jupyter Lab, which is having other tools also. I'm maintaining my kernels, I'm maintaining my tabs, I'm maintaining my files also. I can create multiple folders, I can create multiple files here. Alright, this is a Jupyter Lab.
In company environments, I'm good at programming and I'm not good at dealing with these environments.
Okay.
This is one scenario. Another scenario is I'm good at environments and not good at programming. So what kind of tools I will be able to do?
You can ask your DevOps engineers to create the environment and give it to me. That's the project requirement. I am just going to code. That's the standard. I don't know how to install the Chrome, but I want to browse the internet. So installation will be done by somebody who is going to handle the installation. You will not be able to install. No software will be allowed to install by developers. So installation will be done, maintenance will be done by maintenance engineers. You'll only be coding. You're not allowed to install because you don't have permission to install. Else you install any other software or malware you install and exploit the data. So you are not allowed to install. Okay, the security engineers will install.
And if I'm not good at coding also, and but good at only dealing with this environment, so where I will do
Maintenance engineers who understand environments, installation software, versions, everything. They are everybody is having a those are the skills.
so we should do at least one thing.
Obviously, perfect. All right, all of you. I hope you understand that. Yes. No, actually that because there are a lot of environments. I should not come here and launch that environment. Well, I'll tell you shortcut. Okay, I have a file here, and I have a program, and I want to execute this one in the different environment. Okay, which I have selected and I have created already, and I am maintaining that. For that, you have to go in this part. Can you see this? You see select kernel. So when you click on that, this dialog will open. So here I have to select any of my packages that are available with me. If you don't see the list there, because only two things it is showing. I have to click on select another kernel. Just try it in a system if you can see that. If I click on select kernel, it will give me two options: Python environments as well as existing Jupyter server. That means if you are already running some server on the browser that you have just now tried, you have to give that server or you have to give me environments. So presently you are interested in environments. Let's go to Python environments. Click on that. Once you click on that, you have list of environments that you have previously created. Now you have to select whichever one you are actually looking for. Is that alright? Okay. So now I will select any one of them. So there are other environments. So I select this one. Yes, it is selecting. It is installing IPY kernel. It is installing it as a package. Okay, it is creating the environment and allowing me to execute. Can you write? You got it?
Confusion.
What confusion you tell me?
So we selected base Python.
Base
Then select
is
another.
you click on select kernel, then
Then base.
try it, click on select kernel, do it now. Select kernel, click it, then what option you will see?
So base Python env1 notebook Python 3.10.
Select another kernel, last option.
No, sir. After selecting that one,
Okay, in between that, what do you want to select in that? What environment? No, notebook is different. You have created IPY kernel. Install. Install. So now it has selected env1. So in that, whatever packages I have installed, those packages will be used here inside this environment. And based on that, it's running it.
So for this program, you change the environments.
Correct. If I open another IPynb file, for that I don't need this environment. I will change that also. I go to different file and I will change that. That is how I have freedom to change my environments. I go to EMI calculator. In that I will not use that env1. I use the another one. I use the P version 3.11. Now it will install its own packages. And once it is installed, it is ready to execute. It's ready. Now it is selected this one.
So every time while running the program, it will ask us to change the kernel.
No, obviously by default it is available. Base is available as by default. If you want to change it, you have to change. X base is obviously working as it is.
So we need to click on base and then run it.
No, not a base. But here for example, I go to this IPynb and presently select kernel is option is open. But I am not clicked it. But what I do, I just click on run.
So it will run with its existing base.
So now I click directly on run. Now it will ask me which kernel you want to use it to run it. Okay. Even if you do not select it, it will ask you to select. That's it.
But I created some more versions also, sir. Like P version 3.11, P version 9 also.
Okay.
That's not get displayed here, sir.
The first display doesn't have any option. It has to display. You have the packages available.
If we have 3.9, it is at the last step.
Yes.
But it is getting displayed with some data marks.
That's warning.
Warning for
That means there are few packages available in that. But it says the Python runtime and IPOMP will be automatically installed upon selecting this environment. There are some packages which are missing, which may not allow you to run all the programs it is saying. But when you click on that, it runs all the it will install all the packages which it is missing.
what's the global environment, sir? That is the base environment.
Global environment is space. Globally, it is available. Python version is 3.11.
On that version, the environment is present.
Yes. No, that's not the meaning. You have different versions also, like 3.9 is also having. This my 3.11 is global version of Python that I have. From that also you can run it rather than creating an environment. Other from Python 3.11. Is it okay?
Yes.
Any questions you have? No? You should be very comfortable in using the Jupyter Lab, Jupyter Notebook, Anaconda, creating environments, removing environments, and changing the environment, switching between multiple environments. Okay? And also how will you maintain the multiple versions of different same packages in multiple environments. This capability you must have, this skill you must have. In this list, if you have any questions, just let me know. I'll just give you that. Yes, any questions you have?
Environments we can create, change, delete.
No.
What else other things we can do with the environments?
Environments in the list, no, this basically. We are going to create it, we are going to remove it, we are going to update, activate it. Folder, we are just creating inside that folder, and we are whatever we are going to do, that we are going to do. If anything else I want to do, I will create one more folder like this. That environment is my one more folder. Yes, all of it done. Understood? No questions? All of you able to do? 9. What is it? Someone install all the software and start doing. We have completed today Anaconda. About Anaconda and how do we use that? How do we make use of that in our work or in our project? Or how do we make use of that Anaconda to maintain multiple versions of software or packages? And Jupyter Notebook also we have seen, and we have seen different places where Jupyter Notebooks can be used. Alright, we have seen in an Anaconda website, we have seen in an Anaconda software offline, and we have also seen a Jupyter Lab, which is giving us more capabilities more than Jupyter Notebook. Fine, and we have also seen the same Jupyter Notebook in your VS Code. VS Code, we have already installed extension for Jupyter Lab, Jupyter Notebook, and there they are able to create an IP binary file, and we are able to open that file, and comfortably we can create multiple cells and execute. This much we have understood. I am assuming. Is that okay? All right. So next class we start with the NumPy basics, and all these three packages are very important for everybody who is just getting started with Python, and those who are having advanced knowledge in Python, and those who want to go anywhere around the Python, they need these packages. Without these packages, you will not be able to give any kind of interviews in Python. Right? That much basic it is. That's why it has been told Python for AI ML is the module's name. Alright? So it's very important. These PPTs I'm going to upload on my GitHub and be sharing that in my WhatsApp group, the group that we have. And I want all of you to read it and upload. So that we'll be having more brief on the amazing from my side. All right, we stop here today. We'll meet tomorrow again.
Is other days.
No, it is practical. Let's see that.
Already we have discussed about this Nampai Panda.
But not in detail about programs. We're not making kind of programs. We're not done. We need to do that on this one. Few slides will be having theory obviously. We need to talk about what those packages are. Then we have all the programs. As you can see, because you have more capabilities being unlocked with the help of these packages. All right. Okay. We stop here today. Thank you for joining. Tomorrow we'll continue.